All right, so we're here talking about rectangular arrays. All right, and a rectangular array in math is one way that you can express a multiplication number model. Rectangular array is basically just an arrangement of objects, whether those objects are dots on a piece of paper or counters. It's an arrangement of objects that make a rectangle. So for example, this arrangement of dots would be a rectangular array. Put a rectangle around it. Okay. To be a rectangular array, you need to have the same number of objects in each row and the same number of objects in each column. So our rows go horizontally, they're side to side, left to right. All right, think of the horizon. And we have 1, 2, 3 rows. 1, 2, 3. And there are 2 objects in each row. So far, so good. And we have 2 columns. 1, 2 columns, up and down, vertical. All right, and we have 1, 2, 3 objects in column 1, and 1, 2, 3 objects in column 2. So that makes sense. There are no gaps. Okay, there are no missing pieces here. This right here would not be considered a rectangular array. Although you can draw the rectangle around it, we're missing a piece in the middle. There would be 1, 2, 3 rows, but row 1 and 3 have 3 objects, and row 2 only has 2 objects in them. Same with the columns. Row 1 and 3 have 3 objects in them, and row 2 has only 2. So that would not make any sense. Also, for a rectangular array to be a true rectangular array, can't have something like this either.
Sorry for the interruption. Just a reminder, we are all teachers and paraprofessionals at AIRS Ryle site tomorrow beginning at 8 o'clock and it's 8 until 1 o'clock. And we're combining with AIRS and we are doing a workshop from Scott Forsman on the new series. And the reason we're combining with AIRS is because they got the new series as well. And then after, they will be switching, and then Janelle and Negan, the 2 reading coaches, are going to do other work with us. So again, it is at AIRS. And November 5th, AIRS is here with us at Centerville. If you have any questions, please don't hesitate to ask. Thanks.
If you want to join us for the Scott Forsman training tomorrow at AIRS, you can. We have a new Reading Street program, and that was Ms. Pressman giving us a little announcement. So one of the last things I want to say about rectangular arrays are that squares can be rectangles. Okay, but rectangles cannot be squares. So we had an argument in class the first time we did this about whether this is a rectangular array or not, because it's, 2 rows and 2 columns, 2 objects in each row and 2 objects in each column. And we did figure out that yes, this can be a rectangular array because squares can be rectangles. The last thing I want to talk about is how to name the rectangular arrays. And you want to think about it like this. R times C, or row by column. Row, row, row your boat gently down the column is one mnemonic device that we talked about in class. So to name an array, we go rows by column. So again, back to this example. How many rows does this rectangular array have? It has 1, 2, 3 rows. Okay, there's the 3. And by how many columns? 1, 2 columns. This rectangular array is a 3 by 2 rectangular array. If we have the opposite, they give you, let's say, 4 by 6, all right, you know that the 4 represents the rows and the 6 represents the columns because we're naming it 4 by 6, rows by columns. So I'm just going to do small dots here. It would be 1, 2, 3, 4 rows. 6 columns, 1, 2, 3, 4, 5, 6. And then we can fill in the empty spaces all the way down to successfully make a 4 by 6 rectangular array. Okay. One more thing. Again, rectangular arrays, they're used to represent multiplication number models. So 4 times 6 equals 24. In this, we have the product. Product is the answer to any multiplication problem. Okay? And these two numbers right here are called factors. And this is a factor pair for the number 24. 4 times 6 is 24. 24 is the product. 4 and 6 are factors of 24. And 4 and 6 are a factor pair of 24. All right? In the other video, we talked about factor rainbows, and with factor rainbows, that's one way you can find all the factors of a number. All right? So, quick little tutorial about rectangular arrays, what they're used for, how we use them in math, and let's give you a couple quick test videos here, a couple questions if you want to test yourself. If you want to test yourself at home, how about this one? Make a 3 by 4 rectangular array. All right, you can stop the video if you want and practice that. The answer would be 3 by 4, 3 rows by 4 columns. So 1, 2, 3 rows by 1, 2, 3, 4 columns, and fill it in. That's 3 by 4. You could also do something like this. Do all the rectangular arrays you can for the number 12. Okay? Stop the video and try that one. And the answer would be, okay, I think there are 4 of them. You can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This has one long row with 12 columns. That's a 1 by 12 array. You can do the opposite. The commutative property of math is you can turn these around and still get the same product. Okay? So you can do one long column with 12 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's your 12 rows by one long column. Then you have 2 and 6. Okay? We can have this one. Two rows, 6 columns, 2 by 6, and just the opposite. You could do 6 by 2. One, 2, 3, 4, 5, 6, and fill it in. Those are all the rectangular arrays. Oh, I'm sorry, I'm missing one. 1 and 12, 2 and 6, and then 3 times 4, right? So you can do a 3 by 4. 3 rows by 4 columns. And then a 4 by 3. It'll look really similar, a little bit different. 4 rows. Sorry, 4 rows, yep, by 3 columns. And I think those are all the arrays for 12. All right, awesome, sounds good. And thank you to Sophia for filming this for me. Thanks, Sophia.